Okay, so good afternoon po ulit sa lahat. Here I am again, Sharday, and then I will be talking about now our second part of our talk or my talk in Proportionately 2. And in this part, we're going to talk about inverse proportion. Okay, inverse proportion. So I'll just show this again as a slide. I showed this later a while in the first video. This is again, proportionately po is one of the sub-sutras. Again, in Vedic mathematics, it's the first sub-sutra, first corollary po. This is it in Sanskrit. This is it how you read it in using the alphabet. And these are my sources for this lecture. So this is proportionately 2 already. So we're going to talk about inverse proportion this time. So by cross multiplication, that's our rule, or say the product of the means is equal to the product of the extremes of two fractions or two ratios. In the previous section, we obtained equal products AD and BC, equating both products to K. Okay, for example, K equals AD, B equals B, K equals BC. We can say that the factors A and D are inversely proportional to each other with K as their constant of proportionality. Okay, how is that so? So imagine, just imagine, K equals AD. So if we're going to get the value of A, we need to isolate A. So D will be down on the other side. So it will look like K over D equals A. So I think you can imagine that. Also likewise here. The same can be said to the factors of BC. For example, imagine BC equals K. We want to get the value of B. So we need to isolate B, meaning transposing C to the other side. So what we have is K, or rather B, okay, B equals K over C. So that's inversely proportional. As one increases, the other one decreases, and the reverse. Okay. The equality above means that we can change the factors in a multiplication and get the same result. Okay, that's the same result. We will use this principle to simplify some difficult multiplication in our future Vedic math lesson. Okay. Um, so yun po, at least you'll have the basic concept of how we will use the inverse proportion here. So one example is we're going to still use the doubling and halving. Okay, even though this is additional applications, since Gauri already gave you this in her lecture. So example one. So we have solve 14 times 9. This is fairly straightforward, teachers, but there's a better way to visualize this and answer this problem. Okay, inside our minds. Okay, inside our minds. So 14 times 9. Let's put that there. So 14, example one. What we have is 14 times 9. What we can do is we will have, or we will get the factors of this 14. We'll get the factors of this 14 so that it will look like in the end that will be doubling. Okay, so or also we can do this with a 9. Okay, with a 9, but we cannot have that, so just let it be. Just let it be. Since we can do that, so we can write 14 as something like 2 times 7. Okay, 2 times 7, and then copy off the 9. What we'll do then is multiply 7 times 9 first. 7 times 9. So by multiplying that first in our minds, what we'll have is 2 times 7 times 9 is 63. 63. And then doubling that will give us 12 6 or 126. Okay, so this is I mean you can do this simple calculation, of course, no doubt about it. But the thing is, here in Vedic Maths, what we are up to, what we're offering here actually is the new point of view. You can get the half of this 14, so that in such a way it will become 2 times 7. Multiply the 7 times 9, and then what you will do is automatically in our minds we're going to double that product. Okay, and doubling comes in natural in all of us. Okay, doubling. Instead of this, we're going to have the long multiplication. So it's going to be 14 times 9. So 14 times 9, so 9, 36. Yeah, pretty much we have the same number, 126. But actually, this is quite a long process inside our minds. Okay, compared to this, well, it's kind of long to write, but once you're used to it, teachers, I assure you this will be okay faster than this. Okay, because you don't need to solve. Okay, you don't need to write it. Okay, these processes are just in our minds. Okay, just in our minds. So again, 14 is 2 times 7. Okay, 7 times 9 first, 63. Multiply that by 2, so that's 126. Or by doubling it. Doubling it. Okay, so that's the inverse proportion that we're talking about over here. Okay, so let's continue to our slides. So the answer is 126. Another example. So how about 14, or rather 18 times 4? 80 times 4. So let's have example number 2. Example 2. So we have 18 times 4. What we can do is have as much as we can. So this can be halves, this can be half. So what can we see? We can see 9 times 2 times 2 times 2. So what we're going to have is um, we can do first the the 9. What we can do with the 9 is double it 3 times. Okay, double it 3 times. Or if you want, we can get the 4 here. If we're not it can be that we will not anymore um going to half the 4 or get the factors of 4. Then do it like this in a moment. So we have here 2 here, 2 times 9 times 4. So what we can do first is 9 times 4. 9 times 4 is what? 36. Okay, double that, 36. Okay, and then what we have is the answer. What's that? 72. 72. Okay, and this is our answer pretty much. Okay, so how do we get that? We got in our minds that 18 is 2 times 9, 9 times 4 first. That's a bigger number, and then double it. Okay, 9 times 4 and double it. Okay, take note, we're not taking like 2 times or doubling as another operation, but it's an automatic. Okay, an automatic instinct, shall we say, in our minds. The double is just automatic. Okay, so that's 72. Okay, that's 72. Um, moving on. Okay, the answer is 72. Another example. Let's put some word examples here. Word examples. So let's say if 3 men complete a job in 5 days, how long would it take 4 men? Again, if 3 men complete a day or complete a job in 5 days, how long will it take 4 men? So let's put it here. Um, let's have some space over here that we can solve. Okay, this space is ours. Example 3. If 3 men complete a job in 5 days, how long will 4 men complete a job? Okay, if there are 4 of them. Okay, so recall. In our indirect proportion, this is totally different, okay, compared to the indirect proportion, or rather, our direct proportion. So for the direct proportion, we do something like this, okay, times divide. We're not going to apply that in inverse proportion. Okay, we're not going to apply that in inverse proportion anymore. What are we going to do? Now, we're going to do something like this. Not the crossing something, but we're going to first start off here with the 5 still here, but all across going back. Okay, so we multiply here and then we divide. Okay, so 3 times 5, there's no there's nothing to cancel. If ever, okay, teachers, if ever, participants, if we're going to cancel something, it will be cross. So clearly, 4 and 5 are relatively prime, so we cannot cancel them anymore. So we have 3 times 5 is 15. 15 divided by 4, this is an improper number, so we need to convert it into a mixed number. So we have how many 4s and 15? So we have 3, that's 12. We have the remainder of 3, and the divisor is 4. So that's it. 3 and 3/4 day. Okay, or 3 3/4 day. If you want in decimal, 3.75 days. Okay, so that's how you answer it in number 3. Okay, 3 3/4 day. Okay, number 4. Okay, I think it's your turn. Okay, it's your turn. If 6 men complete a job in 8 days, how long will it take 5 men? Go. Okay, so I think you have the answer already. Is your answer okay? I'm going to reveal it now. Is your answer like this? Okay, congratulations if it is. Okay, 9 and 3 over 5 days or 9.6 days. Um, how did we get that? Here we go. So for example, 6 men is to 8 days and 5 men is to X days. So since this is indirect proportion, it's indirect because it's the number of men, okay, and compared to the number of days. So the more men you have, the lesser days it will be to complete the job. The less men you have, the more days it needs to complete the job. So we will do it like this. This is multiplication, this is division, and we cannot cancel anything across. So 6 times 8 is going to give us what? 48. 48 divided by 5, what's the answer? So we have 9 because 45 is a multiple of 5 and then there's 9 of it and we have a remainder of 3 and the divisor is 5. So yeah, that's the answer. For number 2, or for number 3 and number 4. Okay? Hopefully it is clear now. Okay, moving on. We're going to multiply now numbers ending in 5. Actually, multiplying numbers ending in 5 will be much easier. Okay, recall our division. Okay, with 5. Okay, it's easier now. If we're multiplying something ending in 5, it will also be easier features. Okay, so how will that be? Okay, let's put it in writing or in practice. Let's keep some space for example number 5. Okay, example number 5. Find the product of 342 times 5. Okay, so we're going to get the product of 342 times 5. Actually, what we can do is we're going to apply doubling over here. Okay, doubling. Okay, or halving. Okay, actually the concepts are similar. So here in 342, we can see that it's an even number. It ends with two. So what is the other factor? So let's divide this by 2. 1, 7, 1. Okay, 1, 14, 7, 2, 1. And then let 5 be 5. Okay, so let's write it again. So meaning this is equal to 2 times 171 times 5. Okay, and then what will we do then? We transfer, or by commutativity, 171 times 2 times 5. We do this first. Okay, 171 times 10. And then what we'll have is 1710 because there's just a 10 here. So meaning this is our answer. 17110. Rather, 1710 rather. 1710. Okay, 1710. Actually, this is equivalent to saying like 342 and then times 5. Let me write that again. This is actually equivalent of saying like we will divide, we will half the 342 and we will double the 5. That's actually equivalent of saying that. So if we have this 342, okay, the answer is clearly here, 171. If we double the 5, that's 10. And yeah, that will clearly give us or lead us to the answer. Okay, so that's a shortcut. Okay, actually that's a shortcut in multiplying when one factor is 5. Okay, when one factor is 5. So okay, let me share that. Okay, here. Okay, so that's 1710. So a shortcut, this is a shortcut for multiplying when one factor is 5. Okay, so it's thus develop as you can see, half the other factor and a fixed 0 at the end. Okay, half the other factor and a fixed 0 at the end. So we don't need to mind the 5 anymore. Okay, so we don't need to mind that. So we just need to mind the number that is being multiplied by 5. So we'll half that and then affix a 0. Another application. So here, example 6. Multiply the following by 5. So letter A, we have 824. Letter B, we have 563. Let's give some space for that. Okay, maybe we can put it here. Okay, so for example 6, we are said to do multiply the following by 5. So We have blank by 5. Okay. So for letter A, we have 824. For letter B, we have 563. So what are we going to do? Half it and put a 0 at the end. Okay, half it, put a 0 in the end. So half 8, 4, 2. Clearly, it's 4, 1, 2. Put a 0 in the end. Voila, that's your answer. Yeah, that's it. That's the answer. Now, letter B, half it, put a 0 at the end. 2, 8, 1, 5. And that's it. We don't need to put a 0 in the end because actually it's the answer is 281.5. So if we're going to put 0, so we will extend it. So it just becomes 1,000. So 2,815. Okay, 2,815. Okay, so continuing in this manner, so we have 4,120 and 2,815. Take note, this doubling and halving technique works well whenever the factor, one of the factors ends with 5, provided it ends with 5. That works pretty well. For example, we have to multiply 35 by 16. Okay, oops. Okay, for example, again, we need to multiply 35 by 16. Okay, so let's have some space over here. Okay, here. So multiply, example number 7, multiply 35 by 16. Okay, so if we'll do that, like we said, it's applicable whenever the numbers, okay, whenever the numbers have, okay, a factor that ends with 5. So how do we do that? We're going to like the same concept. We're going to half this, double this, double, half. Okay. Anyways, there's no sense to half the 5. It will be the decimal, so it's not gonna be that good. 70 times 8, and I think that's better. Okay, we can just put 7 times 8. What is 7 times 8? That's 56. Add a 0. Yeah, pretty much that's the answer. Okay, so that's how we do. Okay, when one factor ends with 5. And also take note as an additional, okay, this process of doing this in one of the factors ending with 5, this can be repeated as many as necessary. Okay, for example, we'll compute the following. Okay, all of them are ending with 5, right? All of them are ending with 5. So let's see. Um, Let me transfer this to one with a bigger space. Here you go. Okay, so for example 8, we have for letter A, 48 times 25. Letter B, we have 36 times 75. Letter C, we have 56 times 125. Okay, and let's do this. Let's do this. Okay, so for the 48 times 25, okay, we're going to double the 25, half the 48. Okay, half the 48, double the 25. Okay, if we do that, what will happen? 48 divided by 2 is going to give us 24. 25 times, or rather, this should be 5. I'm sorry, should be 5. This should be 2 rather, doubling. Okay, multiply by 2, and that will give us 50. 50. Now try to imagine this 50. If we're going to move one step further, this 50 will become 100. And you know, multiplying by 100 is always going to be easy. So let's continue. We'll divide this again by 2. We will multiply this by 2. Okay, doubling and halving. So this becomes 12. This becomes 100, and voila, this is going to be easy as 1,200 or 1,200. Okay, 1,200. Number or letter B, 36. Divide this by 2, halve this, double this. If we do that, what will happen? This becomes 18. This becomes 150. Okay, better yet, again, if we're going to apply it again, the doubling and halving, half this, double this, what will happen? It will give us 9 times 300. And this is very easy, pretty easy to do. 9 times 3 is 27. Just input the two zeros. So what we have is 2700 or 2700. Okay. For letter C, I hope you're still with me. Okay, are you learning so far? Hopefully yes. Hopefully yes. So let's divide this by 2, half this, and double this, doubling and halving. So what we have is 2, 16, 8 times double this is 250. Now we're going to apply it again so that we can get a 500 in this part. Double halving. What we have is 14 times 500. So what will be our answer? So 14 times 500 is pretty much easy, but then actually we can still apply, okay, doubling and halving. Okay, 500 is okay, but 1000 is better. Okay, so this becomes 7. This becomes 1000. Okay, and of course, this will give us 7,000. And this is our answer for letter C of number 8. Okay, as you can see, um, maybe you're telling yourself right now, wow, what is this process? This is even difficult, or this is even tedious, or um, you know, it's long, shall we say? Actually, all of this stuff being written here should be in just inside your minds. It shouldn't be written anywhere. It should be inside your minds. Okay, so in such a way that multiply double this, half this, 12 times 100, 1200. Okay, double this, 300, half this, 9, 9 times 300, 2700. Okay, double this thrice, we'll have 1000. Half this thrice, what will you have? You'll have 7, and that's 7000. Okay, so pretty much all of these that I've written are just the mental processes in the brain. You don't literally need to write them down. I am just writing it down for us to visualize what is happening. Okay, what is happening. So that's it for number 8. Okay, hopefully you can get the sense of doubling and halving now. Okay, moving on. This is our solution. 1200, 2700, 7000. Now we can also use the concept of proportionately, specifically in inverse proportion, in removing decimals. Okay, this technique can be extended to decimal and percentages in calculation, since we know that percentages are just decimals. Okay, they are just decimals in another format. So for example, say we'll find the product of 430 times 0.2. Let's put it down, writing. Um, let's move this up. Oops, there you go. Okay, so we have, for example, number 9. Okay, example 9. 430 times 0.2. 430 times 0.2. So instead of doubling and halving, actually the concept of doubling and halving are from the concept of proportionately, because it's being in proportion, that we are manipulating the numbers, but we're manipulating it in a very fair way, in such a way that they are still in proportion, shall we say. This one, we will manipulate them, but not this time by doubling and halving. This 2, if we're going to multiply this by 10, it's going to become 2. And if it's going to become 2, we will result to doubling. Okay, so that it's going to be easy if it's doubling. So if we're going to multiply this by 10 by proportionately, we will be not also we will be dividing this by 10. We will be dividing this by 10. Maybe this by the same process that we did before. That's the reason why. So if we do that, 430 divided by 10, just erase one zero. 0.2 times 10 is going to give us 2. Double this, 86. Yeah, voila. That's your answer. Okay. That's your answer. Or actually, if you want to have it in words, that's 86. Remember? 86. Remember that? The solution is 86. We can simply move the decimal point in 2. This is what is happening. Move the decimal point in 2, one place to the right. One place to the right to make it whole. While, okay, so that we can get back that moving procedure in here in the 2. We move the decimal point of 430 going to the left. That's in the opposite direction. Okay, that's in the opposite direction. In such a way that if it will become move here, we have 2. Move the decimal point on the 430, it will become 43. So double the 43, which will be an automatic mental process then. Okay, so that's it. Example 10. We'll have decimals this time. Decimals. Let's give it. Let's put that on the writing. So example number 10. Example 10. What is 11% of? So take note in mathematics, of is always a multiplication sign of 2700. Okay, so again, we can rewrite this 11% as 0.11. I think that's good already. That's understood already, okay, by everyone. So 0.11. Okay, so what we need to do, we need to make this 11 as a whole number. Okay, so by the same procedure we did before, or the same reasoning, we'll move this twice to the right. We'll move the decimal point here to the left on the opposite direction to compensate. So what we have is 11 times 27. And I think you have this special multiplication case. So we have 11 times any number. So we have 2, 2 plus 7 is 9. Copy the 7. So that's your answer, 279. 297, sorry. 297. Okay, that's your answer. Moving on. That's your answer, 297. For number 11, another example, 84% of 10. 84% of 10. I think that's pretty much straightforward. I don't need to write that. Imagine 0.84, move it twice. So what you or move it rather once. So what you'll have is 8.4. We'll move also the 10%, the decimal point on 10% twice to the left. That's going to give us 1. So 8.4 times 1. Okay, identity property of multiplication, it will tell us that that's the answer. Okay, that's the answer. 8.4. Okay? Okay, how about this? Teachers, participants, students, can you answer this? I'll give you time to answer this, okay? Maybe I can pause the video right now, okay, to answer, or maybe you can pause the video. Okay, so what's your answer? Actually, you can still apply the same concepts that we did. The answer will be, okay, congratulations if 36 is your answer. Okay, thank you. Congratulations. But mind you, there's actually a trick in answering these kinds of problems. Maybe this is a special case for this number example number 12. So let's see. Example 12. You'll be amazed. Okay, there's a little bit of algebra going on. So we have 36%. Let's put a line here. 36% of that's 20. That's multiplication times 25 plus 75% of that's multiplication 36. What's the answer? First off, we will be okay. Okay, we will be converting them to decimals. So what we have is 0.36 times 25 plus 0.75 times 36. And how about this? What if we're going to apply this trick over here, this number 10 trick, this one, this trick to this part of the expression? Okay, so if we do that, what will happen is this decimal point over here will move twice to the right. And the decimal point here in the 36 will move twice to the left. And doing that will result in 0.36 times 25 plus 75 times 0.36. Maybe if you want, we can rearrange it. 0.36 times 25 plus 0.36 times 25. If you want, we can put groupings, parentheses there. Can you see something? from there? Okay, I hope you can see that there's a common factor of 36 here and here. A common factor of 36 here and here. And one more thing, I got a mistake. This should be 75 instead of 25. My bad. Okay, now what will we do? We will get that common factor out. Okay, just like in algebra. So what we do is 0.36 times. Okay, we're going to apply this addition. Okay, this addition to that whatever's left. So we have 25 plus 75 since we have taken out 0.36 already. So adding these numbers, it's very peculiar to see that it's going to become 100. 100. Though in the first part, how can we even tell that we can combine 25 and 75 since 75 is a percentage? Okay, so as you can see in the end, we did add them. Okay, we did add them, and that's 100. And then 100 times 36 is just literally, okay, moving this decimal point twice to the right. And that will give us the answer of 36. Yeah, and that's how I end up with my answer of 36. Okay, 36 there by using some algebra procedures, the common monomial factoring. Okay, and then we have this thing here that happened 100. So who would have thought it will be 100, and then 100 times any number is pretty much straightforwardly very easy. Okay, it's very much easy. Yeah. Okay, so that's how I answered my example number 12. Okay, so moving on for example number 12. Okay, let's move to the next. I think this is the last one. Okay, in our topics in in inverse proportion. This is refactoring. Refactoring. So inverse proportion enables us to change the factors of a product with changing the results. With changing the results. So just like in prime factorization and complete factorization, we can use the inverse proportion concept, the proportionately, in finding the factors of 48, for example. Finding the factors of 48 will somehow look like this. Let's move this slide over here. Oops. Anyways, hopefully we still have space. Yeah, we still do have space. Okay. Okay, now. So refactoring. This is example 13 already. Oops. Example 13. Now, find the factors of 48. Now, what we're going to do is 48, half this 48, okay? Half this, or we can just, put first the trivial factors. 2 times 40, 1 times 48. Okay, apply this. How do I apply this? Double this, half this. Okay, double that and half that. So we have 2 times 24. Can the process still be made? So yeah, double this, half this. What we have is 4 times 12. Okay, again, can we still continue? Double this, half this. What do we have? 8 times 6. Okay, 8 times 6. And then what else? Double this and half this. Continue. Double this and half this. Um, oh, sorry. Opposite. Double this and half this. What do we have? Continue here. What we have is 4, or rather 16. 16 times 3. And I think we should end there since 3 cannot be doubled anymore. Okay, so what are the factors of 48? So what are the factors of 48? The factors of 48 are, if you will write that in chronological order, from least to greatest. So we have 1, 2, 3, 4, there's no 5, 6, there's no 7, neither. 8, after 8, there's no 9, there's no 10, we will go to 12, and then 16, and then 24, and then the number itself, 48. So how many factors do we have? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 factors. Okay, so that's it. That's 10 factors for number 13. So we can still use the doubling and halving, as you can see. Okay, the doubling and halving procedure in finding the common factors. Okay, so we have 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Okay, so that's it. We have 2, 4, 6, 8, 10. Now, how about this? How about this? This is example 14, second to the last example. So hold on tight, hold on tight. Now, if 10 men can finish paving a stretch of road for 12 days, how many days will it take 15 men to finish the job? Again, if 10 men can finish paving a stretch of road in 12 days, how many days will it take 15 men to finish the job? So let's do that in solving and writing. So we're now in example 14. Okay, so if 10 men can finish paving the stretch of road for 12 days, how many days will it take 15 men? How many days? So this is clearly indirect proportion because the more men, the faster it will finish in days. The less men, the longer it will finish in days. So this is indirect proportion. So we multiply and we divide. But before that, notice here, in this 15 and 12, they have a common factor. Okay, they have a common factor, which is 3, in fact. So we copy 10. 12 divided by 3 is 4. 15 divided by 3 is 5. And then that's x. And then we continue the procedure now. I think we can apply the procedure here. Okay, so we multiply and we divide. What will be the answer? So 10 times 4 is 40. 40 divided by 5. Okay, what's 40 divided by 5? Okay, the answer is 8. The answer is 8, meaning your x is equal to 8. Now, if we're going to follow this, that's going to be 10 times 12, that's 120. 120 divided by 15, what's the answer? Actually, we cannot divide that because that's straight up. Just know that 120 divided by 15 is 8. It's 8. Okay? So if you want to check, 15 times 8 is going to give you 120. Okay, 15 times 8 is going to give you 120. Okay, and that's for example number 14. So meaning it will take 8 days. Okay, if there are only 5 men. If there are 10 men, it will be 4 days. If it will be 5 men, it will be 8 days. Okay. Okay, so we're now here in our last example in our inverse proportion. Okay, so this is our example number 15. So we have here, this is actually quite high, advanced. We're going to make use of some theorem. So the greatest common factor, or GCF, and the least common multiple, or LCM, of two numbers are 6 and 336 respectively. So 6 is the GCF, 336 is the LCM. If one of the numbers is 24, find the other number. Actually, we're going to make use of this theorem. This is found in number theory. I also teach it. So we have the GCD of A and B. This is the theorem. The GCD of A and B times the LCM of A and B is equal to the product of A and B. So actually, this is one part of that. That this shows the relationship of the GCD and LCM of two numbers in such a way that it is just actually the product of those two numbers. So you can see this in my YouTube video. You can search for it. I call this theorem 5. In some books, they may auto call this other number, theorem number. So let's use this concept, and we'll be answering this on a sheet of paper. So here, so we are now on example 15. So we have the GCF. Okay, we will let A and B be the two numbers. Be the two numbers. And we clearly know that A is equal to one of the numbers is 24. So let's call that A. We know the GCD of these two numbers. We will denote it by this, okay, as this GCD of A and B, meaning the GCD of the two numbers is equal to 6. And the LCM, the least common multiple of these two numbers, A and B, is equal to 336. So using the theorem, we're going to use the theorem okay, that states that the GCD of A and B times the LCM of A and B is just equal to A times B. Okay, so we're going to make use of this theorem in this example here, in example number 15. Okay, so since we have these values, we will substitute it all there. So we have GCD is 6, for what we have is 6. Okay, LCM is times 336 equals A. We let our A, the first number, the one number that we know, as 24, and then B. Okay, and then actually, this is actually multiplication here. And we can rewrite this as 6 as 2336 is as 24 is to B. Okay, and we're going to follow the same procedure that we have known for the examples that we have solved already. Okay, so again, we're going to do it like this, multiplying over here and dividing over here. But we need to first make sure that these are not divisible, because that will be very helpful, because 336 is such a big number. So is there a common factor in 24 and 36? Actually, there is. For now, we'll use 4. I don't know, I can only see 4. 6. What's 336 divided by 4? So shall we say 32 is the nearest. That's 8. We have 16 as the remainder, 1 here. That's 16 by 4. That's 84. Okay. And then 24 divided by 4 is 6, simply 6. And this is going to be B. Furthermore, we can further divide this. This is 8 plus 4. This is divisible by 3. Oops. This is divisible by 3, actually. So let's divide this, both of them, by 3, also by 6. So what do we have if we divide that by 3? So we have 6 times 3, 2. That's only 6, like 2. And then we have 24. 24 is 8. And then we have here divide by 3. That's divide by 3. That's 2. Then we have B. And then one more last thing. Okay, we can still divide this by 2. Actually, what we're dividing them by is not their greatest common divisor. That's why we're continuing in this manner. So what we have is 6 times 28 divided by 2 is 14. That's going to become 1. That's going to be B. Meaning the greatest common factor is 24, actually. Okay, so um, let's do it like this. Multiply and divide. Okay, so what remains for us to do is just 6 times 14, because dividing it by 1 is still going to be the answer, right? So that's going to be 6 times 14 only. So what's 6 times 14? Again, maybe we can think of it as 14b 2 times 7. So we can rewrite this maybe as 2 times 7 times 6. What is 6 times 7? That's 42. 42 times 2 is 84. And that is our answer. That's the other number then. Okay, that's the other number. So meaning the two numbers are 24 and 84. Whose GCD is 6 and whose LCM is 336. Okay, so that's our last number for our refactoring and our um, second part of our talk. Okay, that's 84. Okay, so teachers and participants, students, it's your time now to shine. I have here again 5 items for you to answer. And yeah, just take note, the clock is ticking. Go. You have 30 seconds. Okay. Go. Go. Okay. Use the concepts that we have learned about in this talk. Still have 20 seconds. Okay. Carry on. Carry on. I think you're in number three already. We have 12 seconds left. Okay. Finding the factors of number four, I believe. And on number five, uh, and then, so that's it. Let's answer them one by one. Okay, shall we? So for number one, we have 16 times 7. Maybe you can think 16 as 2 times 8. Okay, so that we can have 2 times 8 times 7. 8 times 7 is going to give us 56. Double that. That's going to give us 112. 112. Number two. So we have 45 times 6. 45 times 6. Okay, so what can we do here? 45 ends with 5. So using the common thing that we're doing, so we will be multiplying this 45 by 2 or doubling it, and we're going to have this 6. Doubling 45 will give us 90, and the 6 will become 3. 90 times 3. Okay, 3 times 9 is 27. Put the 0 at the end. 270. Number 3, so we have 432 times 5. So again, what we're going to do simply is we're going to have this 3 and put a 0 at the end, or move the decimal place going to the right ones. So have this 2160. 2160. And what are the factors or the integral factors of 72? Okay, what are the integral factors of 72? Maybe we can answer that on this sheet. So to clearly illustrate it, illustrate it, let's do this. Okay, so for exercises, this is number 4. So in the integral factors of 72, 72 is, first of all, 1 times 72. Um, Double this, half this, that's going to become 36. Okay, double this, half this, let's become 18. Double this, half this, become 8 times 9. Double this, oops, no, should be the equal sign, sorry, equals. Double this, 16, half this, that's going to give us 4.5, but no, we're not going to do that. Okay, 4.5 is not, it's not good, that's not good. Um, what else are we missing? What else are we missing? Mm, let's try to divide this. Okay, let's try to divide this by 3. Okay, 3. Okay, is it divisible by 3? Yes, it is. 7 plus 2 is 9, so that's divisible by 3. So how many 3s are there in 72? So we have how many? 2, 12, 24, right? 24. And then this is equal to double this and half this. We have 6 times double this and half this, that's 12. Okay, can we still have one? Doubling this and having this will give us 6 times 12 still, and doubling the 12 and having the 6 will still give us back on this equation. Okay, and then yeah, I think that's it. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 12. Yeah, that's correct. So if you want to put it in ascending order, so we have 1, 2, what are the factors of 72? 1, 2, we have 3 here, 4, 6, 8, 9, 12, 18, 24, 36, 72. Are we missing something? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's correct. We have 12. Okay, so the answer here is 12. So we have 12. 2, 4, 6, 8, 10, 12. So if you were going to check it, it's still the same. So what is 23% of 50? 23% of 50. So what you'll do is move the 23. Okay, maybe you can just move it once so that we'll have 2.3, and 50 will be 5. 2.3, okay, times 5. Okay, let's put it in writing, shall we? Okay, so exercise number 5. So what is 23% of 50? So this is 0.23 times 50. Move this once going left. We're going to move the 50 once going right. Or the opposite, sorry. This is going right, this is going left. My goodness. The 2.3 times 5. So multiplying 2.3 by 5, what will we have? So that's going to give us what? Um, since we're multiplying by 5, apply the concept of multiplying by 5. We will half this and put another one. Put another one. Move the decimal point one more. That is. So if we're going to have 2.3, what's the half of 2.3? 1. 3 is like 1.5. But since we're going to move the decimal point, or rather, yeah, 15, you can think of this as 30, right? So 2.30. So that's going to be 1.15. But since we're going to move the decimal point once going to the left, as said by the rule, so what we have is 11.5. Okay, and that's our answer for exercise number 5. Okay. Yeah, okay. So that's it. That's pretty much our part 2 of our video, of our lecture, of our talk. Okay, thank you very much. So I think this is goodbye. Okay, thank you very much, teachers, for watching and listening to my talk. Again, it's a pleasure being here. And yeah, I hope, though I wish to see you face to face, but we cannot. So yeah, this will be our new normal, the new normal. So yeah, so thank you very much, and it's a pleasure. Okay, see you soon, hopefully. Bye. Bye bye.